Okay, so let's do a practice problem. Let's do an example if that didn't quite seem okay. Other than this first carboxylic acid, which we should know at this point is 4.7, we have no idea what the pKa's of these other molecules are. But that's okay. If we wanted to rank these from most acidic to least acidic, we don't even need to know the pKa of each one of them. We can rationalize our way out of it. So if we were to think about the groups that were attached, we have a bromine, a fluorine, and a chlorine. And if you have your periodic tables with you, what you can see is you can characterize electronegativity of each one of these atoms. And what you'll find is that the fluorine is the most electronegative, and then next on the list is going to be your chlorine. Chlorine is going to be a little bit lower. Bromine, which is going to be the least electronegative of all of these molecules. So give him a tiny little arrow. And so if you think about each one of these molecules, whenever they have been deprotonated, we can then talk about how stable the conjugate base is. So the most stable conjugate base is going to allow us to determine the strongest acid. So in this scenario, of these three, the fluorine is going to be the best at delocalizing the electrons after you've lost a hydrogen. Okay, so this guy is going to be the most acidic, so this is going to be the most acidic molecule, and then chlorine's still going to be able to pull electronegativity or electrons away from the oxygen, spreading the cloud out a little bit, so this is going to be the next most electronegative and the next most acidic. And then from that, the bromine is going to be better than not having an electron withdrawing group on at all, but it's still kind of a very weak effect. So overall, this is going to be the third most acidic molecule, and then we just have regular carboxylic acid with nothing attached at all, and so in this case what you see is what you get. Okay, so this molecule is the most acidic, followed by this guy over here, which is the least acidic. So now that we've rationalized our way out of that, let's just go ahead and I'll give you the actual numbers. You can actually find these numbers in the literature. This pKa is 2.9, and then followed by the fluorine, this is 2.7, and then followed by the chlorine, 2.8. Okay, so now one thing I want to point out is that at this point, it's going to be very, very, very tempting to compare and contrast between halogenated molecules versus the actual halogenic acid. So in this case, we're going to have HBr versus HF versus HCl. So in this case, the pKa for the HF was 3, and then HCl was -6, and then the HBr was -9. So of these three molecules, HF is actually the least acidic. And then of these three, the HBr is the most. But again, this is kind of an apples and oranges comparison, because for, let's just say, HCl versus this molecule right here, the negative charge is on a different atom. So in this case, if we lost a hydrogen, the negative charge would be on the chlorine, versus in this molecule right here, if we lost a hydrogen, the negative charge would be on an oxygen. So it's kind of an apples to oranges comparison.